Today we're talking about Crown ICFs. So I wanted to start here inside this mock-up of the inside of a building envelope, and I wanted to say thank you to Sean Whitebread, who is on the manufacturer side for Crown ICF, for building this mock-up for demonstration purposes so that we could teach people and educate them about the advantages of ICF construction. Thanks, Sean. Today I wanted to address some questions that we've been getting about the ICF block and the structural integrity of it, and just talk about some general things about ICFs that's important to understand. So in the display around me, of course, we have blocks that are full depth. They're 48 inches. And so this one that I have here for demonstration purposes is a cutaway. So we just cut a piece of it out so that I could show a couple of things that are important to know about how the blocks work. So the thing that I wanted to talk about is this piece that's in the center of the block here, and it's in between on 8-inch centers throughout the structure of the block itself. And why is that important? Because that's what gives the structural integrity to the actual EPS foam from side to side to use it as a concrete form. And we're going to talk more about the building sciences of why that's important in just a minute. So this piece here just shows that you have 1.5 inches in width, like you would like a 2x4 or 2x6 embedded in the wall, and that's your fastener zone. And they're very well laid out on the outside of the block because there's a stripe that goes right down where that piece is embedded in the EPS foam in the form process. So literally what happens is in the wall, the rows will line up so that you can see right where the fastener zone is. And they just sit right over the top of each other all the way down through the wall. And so you have an 8-inch on center fastener allocation instead of what would normally be a 16-inch allocation. And you can put your fastener, we like screws the best. You can use ring shank nails. You can even use pneumatic fire ones too. But this will help to represent or understand what it is that we're trying to get across, which is the width of a normal fastening zone embedded in the actual block itself. The reason I have this piece of rebar for demonstration is that also you can see on top of the block, I'm going to kind of turn at an angle a little bit and then we'll show you a cutaway in just a second. This piece of the structure where the rebar sits is already pre-indented so that you can lay your horizontal fastener rods right down in the wall, and then you can tie them to your verticals wherever they land. The structural component of a reinforced concrete wall goes inside the center of the wall typically, just like every other kind of formed wall, and it rests on the same horizontal plane through the entire wall because it sits on the same row on every single block throughout the wall system, which makes it very uniform and very strong. Okay, this section is so that we can demonstrate visually what it is that we're doing with the ICF and how it's constructed. And this is a really unique build process to the masses. It's not widely adopted, but we've adopted this as our favorite way to build. And there's a couple of reasons. The first one that I typically always tell people is this wall assembly is an R50 equivalent. So you have EPS foam on the outside, EPS foam on the inside. You have your structural components, which is your rebar that we've painted green in here. And then we squirted some foam in here to represent what would normally be the concrete so that they're not super heavy to move around. But this would be full of concrete all the way from the footing all the way to the roof line. Now that's interesting because typically this would just be a foundation install. But with us, what we try to do on all of our builds is we try to go from the footing all the way to the roof line, which we'll get to in a second. So why is the R50 equivalent so important and so valuable to the build process? Well, everybody knows that we're trying to protect ourselves from the outside elements when we're inside of our house. And so the better that we can protect ourselves both from water or water vapor and also from air, you create those two things create a block from the inside to the outside. And then the last thing would be a thermal barrier. So the thermal barrier gives us protection from the temperature that's on the outside. And so that's exactly what happens with this. It's common knowledge with builders that the cost of construction is in the wall assembly. And what I mean by that is how many times do you have to touch it? So on a typical house where they're stick framing, you have to put the foundation in, then you put a floor on, then you put a wall system on. You have to treat the outside of it with some kind of a substrate. Typically it's OSB or zip wall. And then you have to have something on the inside for your finishes, just like every other kind of wall assembly. But what happens is the more times you touch the wall assembly, the more cost you have in it from a labor perspective, which drives a lot of the cost of the wall itself. So here's one of the things that's different about ICFs. On the inside, you can directly apply whatever your finish panel is. Typically it's drywall in a house, and you just screw it right onto the EPS foam. Okay, well, what if you have a 50-foot long wall? It's no problem, because remember, you have those 8-inch increments all the way through the entire wall system where you can fasten whatever your finish is on the inside. So we just take our sheetrock, which is what we have demonstrated here, we screw right in on 8 or 16-inch centers and fasten that to the inside of it. So now we have a finish wall on the inside. The outside, same thing. So we'll walk through what's below grade and what's above grade. Let's cut away to that. Okay, so we've moved over to the other side of our display here to represent what would be the outside of the foundation. And there's a couple of things that we do that we just like this building this way, and some products that we really believe in. So I'm going to start with what would be below grade first, because on the side of this block we have just a cutout strip of a product called polywall. And typically what we do with polywall is we go from the footing and we put the polywall on until we get up to at least grade on the outside of the house, usually plus about a foot or so. And so the polywall gives kind of a protection for the outside of our EPS foam. And then right before we do our backfill, after our foundation drainage pipe is laid in, we'll put like a dimple mat on the outside of the polywall as we're filling up, and hold the dimple mat in there so that the dimple mat really is a protection against rocks and debris and hard soil that would normally push up against there and poke holes in the EPS foam. And so since we don't want that, we want to keep that barrier there. Those are a couple of the products that we use. So then after we're done below grade, then we would move up above grade, which is where typically people put their siding product. And so we just have some sample here of what it would look like just on a normal house, and it works the same way on an ICF home, a constructed building. We have this product right here is demonstrated LP Smart Side. So what we've done is we've took some horizontal lap and we've installed it on those increments that are embedded in the wall, which are 8 inches on center, and we screw those in so it goes right into that structural piece that I showed in the other video. And so it's really simple to put this product on, and it's extremely strong on the outside of the edifice, because number one, you're able to screw it in. Number two, you also have 8-inch on center rows where you can fasten it, which gives you a stronger install. So one of the things that we also get some questions about is when you have um, your foundation or your wall structure in. Let's say we're going 2 stories in this demonstration. We have incorporated into our model here how the floor system would sit inside of the walls, because we're actually going 2 stories. And so what this demonstrates is your partition walls that would be inside your building, because really you don't have framing on the exterior walls. It's already in the block. So you don't have to touch the wall as many times, right? So when we hang a floor system off of the block, we have these embedded hangers that actually are recessed all the way into the block, into the concrete, and then the rebar slides through so that then it's actually structurally embedded in the concrete by rebar, which holds it in place in the wall. It's extremely strong and extremely straight. So I wanted to show this side of the floor system and how it's constructed and how it's embedded into the wall brackets that are on this side. It's pretty common to have some form of a 2x10 floor system with sheeting on it, and then inside the building envelope you would have top plates and then your studs, and then that would go down to a bottom plate. The floor system itself, when it goes over and attaches to the wall, is going into the bracket that I was demonstrating. And so the bracket is embedded in the wall, and then your floor system sits inside the bracket. So the cross members would fall back into and sit inside, and then be fastened on both the inside and the outside of each one of those. So it's extremely strong. So while we're here in this corner, I also wanted to just point out some things, some details about the finish on the outside of the house. It's very typical, at least in our market and in our climate zone, to use a Smart LP product on the outside of the house or something like that. And then that would also go not only your siding, but your trims, and then decorative siding, usually in gable areas and things like that. So what I wanted to point out here is that this is just a typical window install. It's a vinyl window, and it's with a flange, a new construction flange. And so when you look at it from the outside, the trim pieces all around the window and the way that they fit with your siding product are exactly the same as you would normally install, except the fasteners that go through the window would be concrete fasteners, because you're going all the way back into the concrete itself. So it's extremely secure. It's a really beautiful finish around whatever the opening is, a door or a window. And then you can have trims that will butt. You also have Z-flash that will come down and cover up from siding to trims, just like you would on a normal install. So this is our demonstration of a cutaway of what the outside looks like from the ICF construction perspective. Okay, so I'm back in the interior of the building envelope, and on the interior I wanted to talk a little bit about the building science of what it is and the way that we build, in particular with the ICF wall that will go from the footing all the way up to the roof line, which is what we're demonstrating here. So we have a mid-span support or a floor system that's in the middle, and this demonstrates going all the way to the roof line. And so what we did is we fabricated a truss piece, a couple of them, and then we built, and then we spray foamed the underside of the building envelope or the deck that's for the roof, so that we could illustrate how we insulate. So typically we would spray right down onto the building envelope, which would be the wall, the top of the wall itself, to cover that up. And then you have this incredibly efficient interior thermal block. And so we introduce fresh air into the building envelope on a consistent basis to have, because we have a really tight building envelope, it has a fresh air intake that's consistent. It's going on all of the time. So I just wanted to talk about what it is that we do and why we do it. to spray the bottom of the roof deck. This is very popular, although we don't do every single job this way, but we bring it right down onto the wall so that then our building envelope is completely secure. Okay, one more item that I wanted to talk about when we construct with Crown ICF product is all of your exterior walls, and we get this question quite frequently. How do you get your electrical, how do you get your utilities in this outside wall? Well, typically we don't put sewer lines and we don't put water lines through the outside wall. Those would be on the inside of the building envelope. But this demonstrates how we do the installation of the wiring, the electrical system in particular. So this is that channel. This is one of the web locations. This is the other web location. So this is where we would go in between, and we would put the wire in that routed cavity right between where the fasteners go, so that we never have to worry about somebody hitting it with a fastener. Okay, what I wanted to talk about here was that one of the main differences in what you'll see on the interior finish, and it's very typical, is that on a standard house you might have a 2x4 or a 2x6 wall. 2x6 is pretty standard, at least in our climate zone and in our market. But when you build with ICFs, all of your jam depths are much deeper. They're 12 inches deep. So you have a lot more depth this way between the door or the window and the outside of the block. So kind of produces like more of a ledge, more of a deep cavity for where the doors and the windows mount. When you're on the inside, you really don't notice it, although if you look long enough, you can see that there is a difference in the depth.